Okay, so the last video assigned questions on page 509, numbers 35, 36, and 37. And this is with conservation of momentum in 2 dimensions. So question 35 says you have a billiard ball of mass 0.15 kilograms, initially traveling 10 meters per second, when it strikes a second billiard ball, initially at mass rest. Now it doesn't tell you the mass of the second billiard ball. You have to assume it's the same mass. And another question, in a few away, they use billiard balls again, and in that one they tell you they're the same mass, but in this one they don't. But they are, okay? So it says after the collision, the first ball rolls off at 7.7 meters per second, an angle of 40 degrees clockwise from its original. So its original is out like this. Clockwise would be down here. So this is ball 1. So its V1 final is 7.7 meters per second. And if ball 1's going down this, and I think it says at an angle of 40 degrees. And if ball 1 is going down this way, then it's safe to bet the house that ball 2 is going to be going up this way. And you're looking for V2F. Okay? So V1F has a V1Fx and a V1Fy. This is V1Fy. This is V1Fx. Okay, and we can find them because we have the angle and we have the hypotenuse. And we know that momentum is conserved in the x direction and in the y direction. So starting with the x direction, m1 v1 initial x plus m2 v2 initial x will equal m1 v1 final x plus m2 v2 final x. Initially, ball 2 isn't moving, and we're looking for v2fx. So take this term over. So it becomes m1 v1 initial, and initially it's only in the x direction. So v1 initial x and v1 initial are the same thing. Minus m1 v1 final, and the x final component is the adjacent side of this right angle triangle. So it's going to be cos theta is equal to m2 v2fx. Now don't switch the v2fx to v2f cos theta, because then you won't know the v2f or the cos theta. You'll introduce another unknown. So just solve for v2fx. So v2fx will equal m1 v1 initial minus m1 v1 final cos theta divided by m2. And now fill in your numbers. 0.15 kilograms, 10 meters per second, minus 0.15 kilograms, 7.7 meters per second, cos of 40, divided by 0.15 kilograms. Punch all of this into your calculator, get a V2Fx of 4.10 meters per second. Okay, so that's the x component. Now you're going to do the same thing in the y direction. So in the y direction, m1 v1 initial y plus m2 v2 initial y should equal m1 v1 final y plus m2 v2 final y. But if you look in the y direction, m1 isn't moving in the y direction initially, so this term goes to 0. And m2 isn't moving at all initially, so this term goes to 0. So bring over one of your terms, so m2 v2 final y will equal negative m1 v1 final, and the y is the opposite side, so it'll be sine theta. So v2 final y will equal negative m1 v1 final sine theta 1 over m2. m1 and m2 are the same here, so we can actually cancel these out. So negative 7.7 meters per second sine of 40. So v2 final y will be equal to negative 4.95 meters per second. where the negative just means opposite number 1. So number 1 was going clockwise, downward. This one then is going to be going up. So now that you have your v1x and your v2x and your v2y, you're just going to draw them. This will be your v2fx, and this will be your, should be a little longer, v2fy, and so this will be your v2f. v2fx was 4.10 meters per second. This one was 4.95 meters per second. Square them, add them together, take the square root, and get a v2f of 6.427 meters per second. And now find this angle, and I would do tan, the 4.95 meters per second over the 4.1 meters per second. And when you do, you get an angle of 50.37 degrees. And which way is it moving? It's moving CCW, counterclockwise, the original. And this is your answer to number, 35. Okay? Number 36. A bowling ball with a mass of 6 kilograms. I'm trying to find the edge of my page. Mass of 6 kilograms rolls with a velocity of 1.2 meters per second towards a single standing bowling pin that has a mass of 0.22. Okay, so we have a bowling ball, and its mass is 6 kilograms, and it's initially going this way. So V of the bowling ball initial is equal to 1.2 meters per second. And it collides with a bowling pin, mass of 0.22, I think. Yeah, 0.22 kilograms, call it a pin, and V of the pin initial is 0. Don't make the pins move, they're hard enough to hit when they're not moving. When the ball strikes the bowling pin, the pin flies off at an angle of 70 degrees counterclockwise from the original. So again, here is the original, and the pin's going this way. This is counterclockwise, and it's 70 degrees. So this is V of the pin final. And it tells us in the givens that its velocity is 3.6 meters per second. Sorry, I didn't realize it was so close to the last question. So this will be V of the pin final y, and this will be V of the pin final x. If the pin's going up that way, then the ball's coming down this way. And you're looking for V of the ball final. Okay? So exactly like what we did the last time, we're going to do it in the x direction and in the y direction. So in the x direction, M of the ball, V of the ball, initial x plus M of the pin, V of the pin, initial x is equal to M of the ball, V of the ball, final x, plus M of the pin, V of the pin, final x. Again, the pin wasn't moving initially. And this time we're trying to find V of the ball, final x. So bring this guy over. So it'll be M of the ball, V of the ball, initial. I can drop the x because it's only moving in the x direction. So V of the ball, initial x, and V of the ball, initial are the same thing. Minus M of the pin, V of the pin, final. And the x component of the pin is going to be cosine because it's the adjacent side. So cosine will equal V of the ball, final x, if you divide this side by M of the ball. Okay, so now fill our numbers in. So V of the ball, final x is equal to M of the ball, 6 kilograms, times 1.2 meters per second, minus 6 kilograms. Nope, that is not 6 kilograms because that's the pin. Minus 0.22 kilograms times final pin was 3.6 meters per second, and it's cos of 70.